7 is over writing equations of parallel and perpendicular lines. It's relatively easy. I need to recall a few things with you. When you see things in y equals mx plus b, or slope-intercept form, you need to remember that m is your slope, or your rise over run, or your rate of change, whatever you want to call it. Okay, and b is your y-intercept, or your initial whatever, initial cost, initial starting point, initial balance of something. Okay, you have to remember that. In order to do our parallel and perpendiculars, it is easiest to put them in y equals mx plus b. That means the y is isolated, or by itself, to put it in layman's terms, it's isolated. Okay, so if that is going to be true, we need to go over what parallel lines have in common. So write parallel down. Okay, going over what parallel lines have in common, you can look at postulate 17, parallel lines. Postulate, again, these numbers are useless to you. You just need to know what they have in them. So parallel lines have the same slope. And in parentheses, I'm going to put m, because that's how we represent slope in most of our equations. So parallel lines have the same slope. So that means if I see something that looks like y equals 3x plus 2, and I identify my slope as 3, then if I have another equation that is y equals 3, let's do this, 6 halves x minus 5, these two lines will be parallel because when I reduce this, I get the same slope. These slopes are the same. Okay? So it's just when your slope is the same. Now if this is in standard form, you would have to convert it to y equals mx plus b to find your slope. But that is the way you would find it. Now for perpendicular, this is a little different. We already knew kind of by definition these lines would never cross, right? Parallel lines never cross, but perpendicular lines do. And they cross at 90 degrees. So if you don't know that already, write it in the little corner there. Perpendicular lines are 90 degrees when they cross. So perpendicular lines have opposite reciprocal slopes.
Question. How are perpendicular lines always 90 degrees?
They're not. Oh, perpendicular. Sorry. I thought you said parallel. Perpendicular, by definition, means 90 degrees.
So the ones that are
Then they're not perpendicular. No, they just cross each other. They're intersecting. So, I totally misspelled reciprocal. Nobody was going to correct me on that. Okay, reciprocal, opposite reciprocal. So to give you a definition of what that really means, if my slope is 2, remember that 2 is really rise over run would be rise 2, run 1. So to make it an opposite reciprocal, I would basically give it a negative, and it would be negative 1/2. So I'm flipping it and making it negative in this case. Had my slope been negative, let's say 3/2, I was going to flip it and give it a negative, so that's 2 negatives, that makes it a positive, and when I flip it I get 2/3. Okay, so that's why I say opposite instead of negative reciprocal. I say opposite reciprocal because if it's positive it turns negative, and if it's negative it turns positive. So opposite reciprocal. Any questions there before I give you an example? Okay. They will give you an equation, or basically an equation for a line. So let's say it was 3/2 x. And then they give you a second equation, y equals negative 2/3 x plus 5. And then it'll say, are these lines perpendicular? and you'll look at the slope, 3/2, and negative 2/3, and you'll say, are these flipped and opposite? Yes or no? Yes, they are. So yes, it is perpendicular. Okay? Any questions before I get into examples from the book? Okay. Let's go ahead and do example 1 then. Example 1A. We're going to practice finding the slope of a line first, because that's important to identifying whether things are parallel and perpendicular, is being able to identify what the slope is. So on this line, I looked at it and see that it intersects at these 2 points. And I can just count it. Rise 1, 2, 3. So the rise is 3, the run is 1. So it's 3/1. Then I look back at it and I say, is this positive or negative slope? Is it rising or is it falling? It's rising. It's going up when I read it from left to right. So it is rising, therefore it is positive. Okay? Any questions there? Okay, if you for some reason love formulas to the extent that you would love to do a formula for this, you can do that using the difference in y's. Whoops. The difference in y's over difference in x's formula. So this is the second coordinate minus the first coordinate, second coordinate minus the first coordinate. And in this problem, they gave you the coordinates for it, so you could have used it if you wanted to. So for the times that they just give you coordinates, let's get this in practice. So this was the coordinates that they gave us. We're going to plug those in right here. So the y coordinate was 0 minus a negative 3 and 1 minus 0. I need to fix this, so that turns into a plus. So I have 3 over 1 minus 0 is 1, and I reduce it all the way down to just 3. Do not leave your slope in 3/1 form. It might confuse you, 1, but 2, that's not in its simplest form. We want to write it as a whole number. Okay? The only time we want to see it in 3/1 form is when we're actually counting it out, rise over run. Okay? Any questions on A? Okay? For B, it says, find the slope of the line parallel to line A. So the slope was 3 here, so what would the slope of one parallel to it be? Let's look back at our definition for what parallel says. Parallel lines have the same slope. So if it is 3 in this one, it has to be 3 in this one. On C, it says, what is the slope of a line perpendicular to it? Looking back at our definition, we're looking for opposite reciprocal. So it's going to be a negative. Uh-oh.
1/3, I'm sorry.
So if I'm going to flip this, it becomes 1/3. If I give it a negative, it becomes negative 1/3. I'm not hearing anything from anyone, so am I safe to assume that we don't know it at all, or we all know it? We're not going to talk, I'm not going to do notes. Example 2. Identify parallel and perpendicular lines. It gives you 2 equations. Y equals 2x plus 4, and y equals negative 3 plus 2x. What is the slope of this line? M would be 2. And what is the slope of this line? Still 2. It's what's in front of the x. So are these parallel, perpendicular, or neither? They're parallel. Okay? This is the symbol for parallel, just in case you see it and don't know what it is already. Okay? So I would say that the 2 lines are parallel to each other. That was A. This is part B. It says, are the lines y equals 2/3 x minus 1 and the lines y equals 3/2 x parallel, perpendicular, or neither? So what is the slope of this one? It's just 2/3. What is the slope of this one? 3/2. Are they parallel, perpendicular, or neither? Neither. They don't have, they are reciprocals, but they're not opposite reciprocals, so it doesn't give us a clear indication that they are parallel or perpendicular. So neither. Okay. Example 3. It says find a line that is parallel to y equals x plus 1. What is the slope of this line?
1.
It's got to be 1. And it says it goes through the point 3, 8. So we have a point and we have slope. So what form should we use when we have point slope form? So remembering that y minus y equals mx minus x. That's point slope formula. I just plug it in. Y minus my y, which is 8, equals m, my slope, 1, multiplied by x minus my x, 3, and I would solve it depending on what form it wants it to be in. If it says put it in slope-intercept form, then I'm not done. I need to finish it out. So I'm going to distribute my 1, which is really silly, and I get x minus 3 and y minus 8. I have to add 8 to both sides. Cancels that left side out. Y equals x plus 5, and that would be my final answer. Okay? Point slope form will be your friend in these problems. They're really quick if you can do that. Okay? And then it'll say graph it. Use your y equals mx plus b. This is your intercept. This is your slope, which is rise 1, run 1. Relatively simple. Okay, example 4.
These are ones who said that no solution doesn't make it. It's a...
Yeah. Example 4 says, find a line perpendicular to this equation, y equals 2/3 x. What is the slope of this line? 2/3. What will the slope of the line that we are looking for be? Opposite reciprocal, remember that. Negative 3/2, because I'm flipping it, right? So the slope of the line I'm going to find will use negative 3/2. Okay? So I'm going to plug it in, and it goes through the point 2, 4. Relatively quickly, I can plug this in. So y minus my y, which is 4, equals my slope, which is negative 3/2, and x minus my x, which was 2. Okay, if it tells you to leave it in point slope form, you don't have to do anything else. But in the event that it doesn't, let's go ahead and solve it for y equals mx plus b, your slope intercept form. So I get negative 3/2 x plus 6/2, which will reduce down to, 6/2, which will reduce down here in a second. Okay, 6/2 reduces down to what? 3. Positive 3, right? So this problem, even though it had a fraction in it, is not as hard as I might have made it seem. If you don't know how to multiply fractions for some reason, you just suddenly forgot everything you've learned in middle school, you can do it on your calculator. You take negative 3/2, and you multiply it by your negative 2. Negative 2. Press enter, blam, it spits out an answer for you. Okay, moving on, I need to get y by itself, so I add 4, I'm isolating my y here, negative 3/2 x plus 7, and I'm done. If I want to graph that again, this is my y-intercept. This is my rise over run, my slope, my rate of change. I just follow it. Make sure it's falling. From left to right, it is falling. That's all you need.